What's up, everyone, and welcome back to All About AI Tech. Today, we're diving deep into the world of vector search and how this cutting-edge technology is revolutionizing how we find information. We're talking lightning-fast search speeds, even for massive datasets. Now, I know what you might be thinking, vector search, that sounds complicated. Don't worry, I've got you covered. We'll break down all the complex jargon into easy-to-understand concepts. And by the end of this video, you'll be surprised at how effortlessly you've grasped the power of vector search and Google's latest innovation, ScaNN with SOAR. Let's start with the basics. Imagine you have a huge library full of books. If you wanted to find, say, all the books by a specific author or with a particular title, that's a job for a traditional database. It's like using the library's card catalog. You input the exact criteria, and boom, you get your results. But what happens when your search is more about meaning and context rather than exact matches? Things get a bit trickier when your search query is something like, find me a Civil War poem that captures the feeling of loss, or I want a science fiction novel set in a dystopian future. See, traditional databases aren't designed to handle these kinds of abstract searches. They rely on literal keyword matching. That's where the magic of vector search comes in. Vector search leverages the power of machine learning to understand the meaning behind your words and find similar items, even if they don't share any exact keywords. Think of it like this. Imagine each word, phrase, or even an entire document represented as a point in a vast multidimensional space. Words with similar meanings would cluster closer together. So, civil war, battle, and loss might be huddled close, while science fiction, dystopia, and future hang out in their own little corner of the vector space. Pretty cool, right? Now, how do we actually create these vector representations? That's where embeddings come into play. Embeddings are like secret codes generated by powerful machine learning models. These models are trained on massive amounts of data to understand language and relationships between words and concepts. So when you input a query like Civil War poem, the model transforms those words into an embedding, a point in our vector space. Once you have your query embedding, the vector database goes to work finding the nearest neighbors, data points closest to your query in that multidimensional space. The closer the points, the more semantically similar they are. And that's how vector search unlocks incredibly relevant results, even for complex, abstract searches. And the applications are limitless. From powering semantic search engines that understand your intent to enabling facial recognition systems and personalized recommendation algorithms, vector search is truly revolutionizing how we interact with information. Just think about it, more accurate product recommendations, finding that perfect song you can't remember the name of, or even matching you with your ideal job based on your skills and experience. The possibilities are endless. But here's the thing, as datasets grow larger and search queries become more complex, we need vector search algorithms that are not only accurate but also incredibly fast. And that's where Google's open source library, ScaNN, enters the picture. ScaNN stands for Scalable Nearest Neighbors, and it's designed to handle massive datasets while delivering lightning-fast search speeds. But Google didn't stop there. They continued to push the boundaries of vector search performance, leading to the development of SOAR. Now, let's talk about SOAR, which stands for Spilling with Orthogonality Amplified Residuals. Sounds complicated, right? Don't worry, the core concept is actually quite intuitive. SOAR is all about introducing a clever form of redundancy into ScaNN's search process. Think of it like having a backup plan. In many engineering systems, redundancy is key. For example, airplanes have multiple systems for controlling critical functions, just in case one fails. SOAR brings this same principle to vector search. Before SOAR, ScaNN used a technique called k-means clustering to organize the data points in the vector space. Each data point was assigned to a single cluster represented by a cluster center. When you submitted a query, ScaNN would first find the cluster centers closest to your query and then search within those clusters for the nearest neighbors. This method works well, but can sometimes miss relevant results. Imagine a scenario where your query is very close to the boundary between two clusters. The actual nearest neighbor might be in the adjacent cluster that wasn't searched. This is where SOAR's redundancy comes in. SOAR assigns data points to multiple clusters, not just one. This means that even if a data point's primary cluster is missed, there's a higher chance it'll be captured by one of its secondary clusters. It's like having a safety net to catch those potentially missed results. But SOAR doesn't just randomly assign data points to multiple clusters. It strategically chooses secondary clusters based on a concept called orthogonal residuals. In simple terms, SOAR tries to ensure that the secondary clusters provide a different viewpoint of the data, increasing the chances of finding the true nearest neighbors. So, how does SOAR actually stack up against other algorithms? Well, the results are impressive. In benchmark tests, ScaNN with SOAR consistently outperforms other leading vector search libraries in terms of speed and accuracy, especially as datasets grow larger. That means faster search results without sacrificing accuracy, a win-win situation. And it's not just theoretical. ScaNN's technology is powering many of the Google products you use every day, from Google Search to Google Photos, and even the Google Assistant. Each time you search for similar images, find relevant information online, or ask your Google Home a question, there's a good chance ScaNN is working behind the scenes to deliver those lightning-fast, accurate results. Now, here's the best part. ScaNN is open source. That means anyone can use it, modify it, and contribute to its development. This openness fosters collaboration and innovation, pushing the boundaries of what's possible with vector search technology. So there you have it, a deep dive into the world of vector search, powered by Google's impressive ScaNN library and its game-changing SOAR algorithm. I hope you found this video insightful and maybe even a tad bit mind-blowing. Don't forget to hit that like button if you learned something new today, subscribe for more AI deep dives, and share this video with your fellow tech enthusiasts. Let me know in the comments below what other AI breakthroughs you'd like me to cover. Until next time, stay curious and keep exploring.